Hi guys, today we're going to be going over the 5-point heating curve for phase change. So on every curve, you'll see that there are 5 sections on it. There'll be 3 inclines and 2 plateaus. Um, on the axes, the y-axis, you have temperature in degrees Celsius, and on the x-axis, you have energy that is added to the compound. So for this, we'll be going over the phase change diagram of water. Now, to start, we're going to start at this first incline, and we first have to label the temperatures. Um, there are only really 2 vital temperatures you need to label for this diagram. Label at 0 degrees Celsius and 100 degrees Celsius. Now, as you can see, both of these temperatures coincide with the plateaus on the graph, and we'll go over what that means later. So first, on this first incline, we have water below 0 degrees Celsius. So we know that it won't actually be liquid water, but it's actually going to be ice. So from any temperature before 0 degrees Celsius at standard pressure, water is going to be in its solid phase. Now, as you add more energy to the water, you see that temperature will start to increase. Temperature will not increase indefinitely. It'll hit this point at 0 degrees Celsius where you see the graph start to plateau. Now, at this point where it goes from an incline to a plateau, something special happens. Now, this is where you start to see the actual phase change from a solid to a liquid. Now, once all of the solid water is converted to liquid, you'll see that once again the temperature will start to increase on the second incline. Now, the same process occurs, except this time, once the liquid hits 100 degrees Celsius, it will start to boil. Now, this is when the liquid water starts to convert into gaseous water or water vapor. And at this second plateau, the temperature does not change, but energy is still being added. However, instead of the energy being put into raising the temperature of the water, it is rather being used to change the phase. So once all liquid water is converted to gas, you hit the third and final incline of this graph, and the temperature will start to increase again. Now, when using this graph, you can use it to interpret many different things, but it's commonly used to solve and to find various values for Q that are needed to raise the water a certain temperature. So there are different equations that are associated with these graphs at different points. Now, along each of the inclines, you can use the equation Q equals mc delta T. Now, you can either be given Q and asked to find change in temperature, or vice versa. You might be asked to find Q given the change in temperature. But just remember that this equation is only applicable for when the compound in question is on one of the inclines. So that's either in between, that's either before 0 degrees Celsius, or in between 100 or after 100. And in the problems you'll be given, it'll be stated clearly whether or not it's on an incline, or you'll have to interpret whether it's on an incline or not. Now, the second, and there are 2 other equations you can use for for the 2 plateaus. So those equations are Q equals mLV or Q equals mLF. LV and LF are called the latent heat of vaporization and the latent heat of fusion. Now, LV and LF are also, they're interchangeable with HV or HF. They both mean the same thing. It's just a different way of writing them, but they're the same values and have the same use. So you'll be using Q equals mLF on this first plateau because this is called the point of fusion. So and the second plateau is when you'll be using Q equals mLV, which is the point of vaporization. So a good way I remember it is just for the second plateau, liquid water vaporizes to gas, and then the first plateau is just fusion, so is either from solid to liquid or liquid to solid. You have to make sure that you also have to convert from grams to moles, because these values for LV and LF are given in kilojoules per mole rather than joules per gram degrees Celsius like C is, so it's just an extra conversion you have to do. But we'll go over a problem later where it's easier to visualize. So once you interpret this diagram and you know where to use each equation, it's relatively simple to calculate Q, and if you go to the next video, we can go over that. All right, see you there.